till now we don't know the value of this. Okay, that is root of -1. So the complex number, if there is a question, what is complex number? What is the answer? A complex number is a combination of real and imaginary number. Okay, a complex number is a combination of real and imaginary number. Okay, in the form of a plus ib. Okay, where a and b are real numbers. Okay, so complex number is just the combination of real and imaginary number. Here, just look, -1. Root of -1 equal to, this can be written as I, or this is called iota, IOTA. Okay, let's find this form. Here, a plus ib. Okay, this is a complex number, and complex number is denoted by z. Okay, so here in z, z means the complex number. Here the a is the real part of z. Okay, and this part, that means ib part, is called the imaginary part of the complex number. Imaginary part of z. Okay, and this real part is expressed by REZ. Okay, for complex number z, and the real imaginary part is written as imz. Okay, for the complex number z. Okay, clear? Hi, how are you? Welcome back to our channel AnganaStudyCenter. Today we will discuss about the complex number and the quadratic equation of class 11th math, chapter 4. You think there is complexity exist? Absolutely no. No complexity. Yes, this is a simple chapter, and I teach you in a way that you never forget this chapter. Okay, the YouTube, you never get this type of video. Okay, let's start our class. So first, we have to learn up to the quadratic equation, like x square plus bx plus c equal to 0. X square plus bx plus c equal to 0 is a quadratic equation, and here the discriminant d is equal to b square minus 4ac is greater than 0. Then the roots of the equation are positive. The roots of the equation are real. Okay, if the discriminant b square minus 4ac equal to 0, then the roots are equal and real. Okay, when the discriminant d is equal to b square minus 4ac less than 0, the roots are not real. The roots are not real. So from here, the concept of complex number has been arised. Okay, so how? Let's see. X square plus 1 equal to 0. Can you find the roots of this equation? No. Till now, no. As you know, to find only the real roots. Okay. We have never read about the imaginary root or complex root. Just see here. This can be written as x square equal to minus 1. Okay. So x equal to plus minus root of minus 1. Okay. So here, till now, we don't know the value of this. Okay. That is root of minus 1. So the complex number, if there is a question, what is complex number? What is the answer? A complex number is a combination of real and imaginary number. Okay. A complex number is a combination of real and imaginary number. Okay, in the form of a plus ib. Okay, where a and b are real numbers. Okay, so complex number is just the combination of real and imaginary number. Here, just look. -1. Root of -1 equal to, this can be written as I, or this is called iota, IOTA. Okay. So let's find this form. Here, a plus ib. Okay, this is a complex number, and complex number is denoted by z. Okay, so here in z, z means the complex number. Here the a is the real part of z. Okay, and this part, that means ib part, is called the imaginary part of the complex number. Imaginary part of z. Okay, and this real part is expressed by REZ. Okay, for complex number z, and the real imaginary part is written as ImZ. Okay, for the complex number z. Okay, clear? So from here we have seen that I equal to root of -1. Okay, I equal to root of -1. If we square I square I, that means iota, we get -1. Okay, so I square equal to -1 and I equal to root of -1. This should be remembered. By an example, we can better understand this method. Here, just look. Here a complex number 4x plus I 3x minus y equal to 3 plus I minus of 6, where x, y are the real numbers. Okay, find the value of x, y. Here, this we have 4x plus I of 3x minus y equal to 3 plus I of minus 6. Here, this is a complex number and this is also a complex number. Okay, as these are in the form a plus ib. Okay, here if there is this type of equation, then we simply equal the real part and the imaginary part. So we have 4x equal to 3 and 3x minus y equal to minus of 6. So from here x equal to 3 by 4, and here we put the value of x, 3 into 3 by 4 minus y equal to minus of 6, or 9 by 4 plus 6 equal to y, or y equal to 33 by 4. Okay, we are now know about the algebra of complex number. In real number there is addition, subtraction, multiplication and inverse. Okay, so here also in complex number there is addition, subtraction, multiplication and inverse also exist. Okay, so how we can we can do the addition of two complex number, subtraction between two complex number, inverse of complex number and multiplication of complex number. How can we do? Let's see. We first know about the addition of complex number. Let z1 equal to a plus ib is a complex number, and z2 equal to c plus id is another complex number. Are complex numbers. Okay. Then the addition, that means addition of z1 and z2 is defined by z1 plus z2. Okay, is equal to a plus ib, okay, plus c plus id. And what will be the value? Here simply add the real part with real part and the imaginary part with imaginary part. So we have a plus c plus I of b plus d. Very simple. Okay. In addition, there are some laws. Laws mean some properties. Okay. Let's see. The property number 1. Here, z1 is a complex number and z2 is a complex number. Then the addition of these two complex number is also a complex number. This is the closure law. Okay, the addition of two complex numbers is also a complex number. Okay, this is closure law. That means if Z1 plus Z2, if Z1 and Z2 complex number, then Z1 plus Z2 is also a complex number. Okay. Okay. Then properties number 2. For every complex number Z1 and Z2, we have Z1 plus Z2 equal to Z2 plus Z1. This is the commutative law. Okay. Okay. Here is the example. Just see. Here Z1 is equal to A plus IB and Z2 is equal to C plus ID. So Z1 plus Z2 is equal to A plus C plus I of B plus D. Okay. So this can be written as C plus A plus I of B plus B. Okay. So this is a form. This can be written as C plus ID plus A plus IB. So Z2 plus Z1. Okay. Very simple. What is number 3? For any 3 complex number Z1, Z2 and Z3, we can write Z1 plus Z2 plus Z3 equal to Z1 plus Z2 plus Z3. Okay. This is the associative law. Okay. Now properties 4. There is a complex number like 0 plus I0. Okay, and it is denoted by 0 is called zero complex number. Okay, or additive identity. Okay, identity. Say that for all Z mean complex number, all Z plus 0 equal to Z. And 0 is the additive identity. Okay, what is number 5? If Z equal to A plus IB, okay, then there exists another complex number, that is minus of A and plus I of minus B. This is the additive inverse of Z. That means minus A plus I of minus B equal to minus of Z. Okay. So we get, if we write Z plus minus of Z equal to A plus IB minus of A minus of IB, that means 0. That means this is the additive identity. If there is addition between the complex number and his additive inverse, then the result will be the additive identity. This would be a short question. Okay. Now we will know about the difference of complex number. This is also very simple. Difference. Let Z1 and Z2 are two complex numbers, where Z1 equal to A plus IB and Z2 equal to C plus IB. So the difference will be Z1 minus Z2. This difference Z1 minus Z2 is written as just difference the real part and the imaginary part. So here A and here the real part is C. So A minus C plus I, here B, that means B minus B. This is the difference between two complex numbers. Okay. difference between the real number and difference between the imaginary part. Okay. We now know about the multiplication of complex number. This is very simple also. Z1 equal to A plus IB let and Z2 equal to C plus ID. Okay. Then the multiplication of this complex number will be Z1 dot Z2 equal to, just apply the formula of multiplication. Here in this complex number the real part A, so with A we should multiply the whole. So here will be C plus ID, and here the rest, the imaginary part, that means by imaginary part we should multiply the whole. So C plus ID. So here we get AC plus I of AD plus I of BC plus I square BD. So here we get AC plus I of, we common I from these two, we get AD plus BC, and here minus of 1 I square equal to minus 1, we have already known BD. So if we segregate the real part and imaginary part, we get AC minus BD, and here I of AD plus BC. Okay, simple, very simple. And by formula we can write this. Okay, so by this, if we here A plus IB and here C plus ID. So first we multiply A with C, AC, and BD. So there will be a part, real part will be AC minus BD. Okay, plus. Then how the imaginary part we will get? Cross multiplication. AD, I of AD minus, plus cross of BC, cross multiplication of BC. Okay, and this will be equal to this. Okay, there are also some properties of multiplication of complex number. First, if Z1 and Z2 are two complex numbers, okay, then the multiplication of Z1 and Z2, that is Z1 dot Z2, will also a complex number. Okay, let Z1 is equal to A plus IB and Z2 is equal to C plus ID. So we get Z1 plus Z1 dot Z2 equal to AC minus BD plus I of BC plus AD. Okay, this is the real part and this is the imaginary part. So this is also a complex number. This law is called closure law. Okay. Now properties number 2. For two complex number Z1 and Z2, we have Z1 dot Z2 equal to Z2 dot Z1. Okay. And property number 3, for any three complex number Z1, Z2 and Z3, we have Z1 dot Z2 within first bracket into Z3 equal to Z1 dot Z2 into Z3 within bracket. This is the associative law. Okay. There exists a complex number 1 plus I0 denoted by 1 called the multiplicative identity of Z for all Z, but Z is a complex number. Okay, either Z dot 1 is equal to Z. Okay, my properties is there exists a complex number Z inverse, that is 1 by Z, is called the multiplicative multiplicative inverse of z. Okay, or z is a complex number. Okay, and we get z dot z inverse equal to 1, and 1 is the multiplicative identity. Okay, and z inverse is the multiplicative inverse. Here a new term, multiplicative inverse. So this is very important. How to find the multiplicative inverse we should know later. Just see the properties now. Okay, we now know about the division of complex number. Let z1 and z2 are two complex number. Okay, then the division of z1 and z2 is written as z1 by z2. This can be expressed as z1 dot 1 by z2. Sorry. Okay, 1 by z2 means the multiplicative inverse of z2. So this can be written as z1 dot z2 inverse. Okay, we now know about the power of I. We have seen that I equal to minus of root of minus 1. Okay, so I square equal to minus 1. Okay, just squaring both, and then I cube equal to I square dot I, that means minus 1 into I equal to minus 1 minus I. Okay, and I4 equal to I square whole square. So I square equal to minus 1 whole square, that means 1. Now I to the power 5 equal to, here I to the power 4 dot I, that means 1 dot I, that means I. Now I to the power 6 equal to I to the power 4 dot I square, that means I to the power 4 equal to 1 dot I square, and the value of I square is minus 1, so minus 1. And I to the power 7 equal to I to the power 4 dot I cube equal to I to the power 4 equal to 1, and I cube equal to I square dot I, that means 1 dot minus 1 dot I, that means minus I. So from this we can write a theorem. If I to the power, there is exist I to the power 4k, where k is any integer. Okay, then I to the power 4k equal to 1, that means this value will be here. Okay, this is formula number 1. And if there is I to the power 4k plus 1, the value will be I. Okay, if I to the power 4k plus 2, then the value will be minus 1, that means this. And if there I to the power 4k plus 3, the value will be minus I. So this fourth formula should be remembered. Okay, now we will learn the square root of a negative real number. Okay, we know I equal to root of minus 1. Okay, so here I square equal to minus 1, and also minus of I whose whole square equal to also minus 1. The square root of minus 1 will be minus of I and I. Okay, but here only we know the I. So by example we can see that x square plus 1 equal to 0, or x square equal to minus 1, or x equal to plus minus root of minus 1 equal to plus minus I. Okay, this is the solution. So minus I and plus I are the solution of this equation. Okay, we know that root of a multiplication root of b equal to root of ab for all real number a and b. Now let a equal to minus 1 and b equal to minus 1. Okay, here just see root of minus 1 dot root of minus 1. What is the value? Minus 1 means I, root of minus 1 means I and dot I, that means I square equal to minus 1. But in this form AB equal to root of minus 1 dot minus 1, and minus 1 will be positive, so root of 1 equal to 1. Here minus 1 not equal to 1, so there is a contradiction. Okay, this example is very important, so this should be remembered. Express the following in the form of a plus ib. So this form has to be convert to this form. So then look, we simply multiply this. We get minus of 5i into 1 by 8i. So minus of 5 by 8 I square. So minus of 5 by 8 I square means minus 1. So we get minus of minus plus 5 by 8. So this can be written as there is no imaginary part. So this can be written as 5 by 8 plus iota dot 0. So this is the a plus ib form. Okay. Similarly, this can be just simplify this. This can be written as minus I dot 2i dot minus of 1 by 8i. So just multiplication this, we get minus will be plus 2 by 8 I cube. Here 2 by 8 I cube means I square dot I. So 2 by 8 I square equal to minus 1 dot I. So minus of 2 8i. So there is no real part. So 0 will be the real part, 2 by 8i, and this can be written as 0 plus minus of 2 by 8i. Okay. In this way, we can express this form as a plus ib. Okay. Express the following in the form of a plus ib. So similarly, like previous, we have to do this. Okay. Here I minus 3i whole cube. So we should apply here the formula of a minus b whole cube. So just look, 5 cube minus 3 dot 5 square dot 3i plus 3 dot 5 dot 3i whole square minus 3i whole cube. Okay. So equal to 125 minus 9.25i plus 27.5 I square minus 27 I. So we have 125 minus I minus 1, as I square equal to minus 1, so we have plus I. So here minus of 10 minus of so this will be the answer. Okay. And for this, just multiply these two. We get minus of root 3 dot 2 root 3 minus plus root 3 of I, and here plus minus of root 2 dot 2 root 3 and plus minus of root 2. This plus will be minus, as here is minus of 2i. So here we get root 3 dot 2 equal to 6 minus of 6 plus root 3i. Here then look, this can be written as minus 2 dot minus of 1 dot 2 root 3, and this can be written as 2 dot minus of 1 dot I. So minus 6 plus root 3i plus root 2 dot root minus 1 dot 2 root 3, and here also root 2 dot root minus 1 dot I. So this can be written as minus 6 plus root 3i, and this is the value of 2 root 6i minus plus this is the I, and I equal to I square equal to minus 1 plus root 2. So this can be written as 6 plus root 2 plus I of root 3, if we common I root 3, therefore 1 plus 2 root 3 root 2. Okay, this will be the answer. Here we will know about the modulus and conjugate of complex number. Let Z is equal to a plus I is a complex number. Okay. Then the modulus of Z equal to root of a square plus b square. Okay. This is the non-negative real number. Okay. And modulus of Z. Okay. Now the conjugate. Conjugate can be written as Z bar. Okay. Z bar equal to a minus ib. Okay. This is the conjugate of Z. Okay. So now here we will learn the formula of multiplicative inverse. Here Z equal to a plus ib. So the multiplicative inverse will be Z equal to Z is Z inverse, that means 1 by Z. So just if there is a question, just find the multiplicative inverse of Z. Just apply this. Okay, this is one formula, and then we will know the another formula. Just 1 by Z equal to 1 by A plus IB. Okay, now just rationalize this. Just write A plus IB and multiply this with A minus IB and A minus IB. Okay, so here will be A minus IB, and here the formula of A plus IB and into A minus IB. So this is the formula of A square minus B square. So just put the value A minus IB and here A square minus IB whole square. So A minus IB and here A square equal to minus 1. So minus minus will be positive plus B square. Okay. So here we can write this A minus IB equal to conjugate of Z. So Z bar, and A square plus B square equal to modulus of Z whole square. Okay. So there is a theorem 1 by Z equal to conjugate of Z and modulus Z whole square. So this can be written as Z dot conjugate of Z equal to mod of Z whole square. Okay. So here we have learned how to find the multiplicative inverse and what is the modulus of a complex number and the conjugate of complex number. So if there is a question, just find the conjugate of Z, just write the real part, then the sign will be the opposite of this. That means here positive, here negative. If there is negative, here will be the positive, and then the imaginary part. So this is so much easier. Okay. Let's do some example. Now look, here is a question. Find the multiplicative inverse of 2 minus 3i. So the multiplicative inverse of 2 minus 3i is equal to 1 by 2 minus 3i. Just write 1 divided by that complex number. Now rationalize that. Okay. So 1 by 2 minus 3i into 2 plus 3i and here 2 plus 3i. We get 2 plus 3i. Here the a square minus b square, that means 2 square minus 3i whole square. So we have 2 plus 3i dot 4 minus 9i square. That means 2 plus 3i 4 minus plus 9. Okay. So 2 by 13 plus 3 by 13. This is the multiplication inverse of 2 minus 3i. Okay. So much easy. Let's look at this question. Express the following form of A plus IB. So this can be expressed as A plus IB. So just rationalize this. Okay. 5 plus root 2i into 1 plus root 2i. And here will be 1 minus root 2i, 1 plus root 2i. Just simplify that. We get 5 plus 5 root 2i plus root 2i plus 2i square. Here we get 1 square minus root 2i whole square. So we have 5 plus 6 root 2i minus 2. And here will be 1 minus 2i square. So here will be 3 plus 6 root 2i, and here will be 1 plus 2. So this can be written as 3 by 3 plus 6 root 2 by 3i. So 1 plus 2 root 2 by cancellation 3 and 6 2i. This is the form of A plus IB, and for this I to the power minus 35. This means 1 by I to the power 35. 1 by I to the power 34 plus 1. So 1 by I to the power 34 dot I. So this can be written as I square to the power 17 dot I. So 1 minus 1 to the power 17 dot I. So the power of minus 1 is odd. So here will be minus 1. So minus 1 1 by I. Now just simplify this. Okay. I of I square. Just multiply both numerator and denominator with I. So we get I square equal to minus 1. This will be positive. So I. So this can be written as 0 plus I dot 1. Okay. Now we will do the exercise number 4.1 of your NCERT textbook. look at this question. Express the following form a plus ib. So here, just simplify this. You get minus of 5i into 3 by 5i. So here 5 will be cancelled, and here minus of 3i square. So this can be written as I square equal to minus 1. So minus minus will be positive, will be 3. So this can be written as 3 plus I dot 0. Okay. And question number second. Here I to the power 9 plus I to the power 19. Okay. So this can be written as I square to the power 4 dot I, and here this will be written as I square to the power 9 dot I, here minus 1 to the power 4 dot I, plus here minus 1 to the power 9 dot I. So the power of minus 1 is even, so here will be 1 dot I, and here the power is odd, so this is minus 1 dot I. So I minus I equal to 0, and this can be written as 0 plus 0, I 0. Okay. And question number 3. Here I to the power minus 39 equal to 1 by I to the power 39. So here this can be written as I square to the power 19 dot I. The power is odd, so this will be minus 1. Okay. So 1 by minus 1 dot I. So minus, here just multiplication this with I, both numerator and denominator, I, and here I square. So I dot minus 1. So this minus minus will be positive I. So this can be written as 0 plus I dot 1. Okay. In this way we can express this. Then look at this question. Express the following in the form a plus ib. So just simplify this. 21 plus 21i plus 7i plus 7i square. So we have 21 plus 28i plus 7 dot minus 1. So here 14 and plus 28. This is the form of a plus ib, and this can be written as 14 plus I of I 20. Okay. Now question number 5. Just simplify that. 1 minus I minus minus plus 1 minus of I 6. So here 2 minus of I of 7. Okay. This is the form of 2 plus I of minus 7. Okay. And now question number 6. Just simplify this. 1 by 5 I dot 2 dot 5 minus 4 minus I dot 5 by 2. Just segregate the real part and imaginary part. We have plus I dot 2 5 minus 5 by 2. So we have okay. Let's look at this question. Express the following in the form of a plus ib. So just simplify this. We have 1/3 plus I 1 by 3 plus 4 plus I of 1/3 minus minus plus 3 minus of I. So just segregate this real part and imaginary part. We have 1/3 plus 4, 1/3 plus 4 plus 4 by 3, and here if we common I, 7 3 plus 1 by 3 minus 1. Okay, therefore we have LCM of this. We have 1 plus 12 plus 4 plus here I, and just simplify this. We have 7 plus 1 minus 3. So 17 by 3 plus I of 5 by 3. This is the form. Okay. Now question number 8. Here 1 minus I whole square, whole square equal to 1 minus I to the power 4. Just apply a minus b whole square formula. 1 minus 2i plus I square whole square. So here we get 1 minus 2i minus 1 whole square. So minus 1 plus 1 will be cancelled. Minus of 2i whole square equal to 4i square. So 4 dot minus 1. So minus 4 plus I of 0. Okay. And question number 9. Just apply the formula of a plus b whole cube. So just 1 by 3 whole cube plus 3 1 by 3 whole square dot 3i plus 3 dot 1/3 dot 3i whole square plus 3i whole cube. Okay. So we have 1 by 27 plus 3 dot 3i divided by 9 plus 3 dot 9i square divided by 3 plus 27i cubes. So we have here 3 will be cancelled and 3 will be cancelled. So we have 1 by 27 plus I plus 9i square plus, here iq equal to 27 dot I square dot I. So 1 by 27 plus I plus 9 of minus 1 plus 27 into minus 1 dot I. So we have 1 by 27 minus 9 plus I minus 27 I. So just simplify this. We have 27 1 minus 3 6 2 4 3 plus I of minus 26 I. So we have minus 242 by 27 plus I of minus 26. Okay. Look at this question. Find the multiplicative inverse of the following complex number. Here 4 minus 3i, here root 5 plus 3i, here minus of 5. We know the multiplicative inverse is written as 1 by that complex number. So the multiplicative inverse of this is inverse of 4 minus 3i is equal to 1 by 4 minus 3. So now rationalize this. We get 4 minus 3i into 4 plus 3i divided by 4 plus 3i. So we have 4 plus 3i whole square minus 3i whole square. So we have 4 plus 3i 16 minus 9 of I square. So 4 plus 3i 16 plus 9 as I square equal to minus 1. So this can be written as 4 by 25 plus I of 3 by 25. Okay. Now for this, the multiplicative inverse of root 5 plus 3i is equal to 1 by root 5 plus 3. So just rationalize this. We get root 5 minus I3 and here root 5 whole square minus of I3 whole square. We have root 5 minus I3 here 5 minus 9 I square. So we have root 5 minus 3i 5 plus 9 as I square equal to minus 1, then minus 1 minus plus. So root 5 divided by 14 plus I dot minus of 3 by 14. Okay. And for this, the multiplicative inverse of minus I is equal to 1 by minus of I. Then rationalize this. We have I and this is I square. Okay. So minus of I and here minus 1. So we have I. Okay. So this can be written as 0 plus I dot 1. Okay. Very simple. Express the following in the form of a plus ib. So just simplify this. Okay. Here the formula of a plus b, a minus b. We should apply. Therefore we have 3 square minus I root 5 whole square. And here just simplify. Root 3 plus I root 2 minus root 3 plus I root 2. So plus root 3 minus root 3 will be cancelled. Okay. So just apply. Just 3 square equal to 9 and here 5 I square. And here will be 2 root 2 I. Okay. Now we have 9 I square equal to minus 1. So this will be positive plus 5 and 2 root 2 I. Okay. Therefore we have 14 by 2 root 2 I. Here by cancelling this we have 7. So 7 by root 2 I. Now rationalize this. We get 7 into I divided by root 2 I square. So we have I square equal to minus 1. So 7 by minus 7 by root 2 and this is I. So this can be expressed as 0 plus I of minus 7 by root 2. Okay. We now know about the Argand plane and polar representation. Here we are going to know about the how the complex number is represented in XY plane. Normally in for real number we hold the x-axis and y-axis. Okay. And here in complex number the real axis and imaginary axis. Okay. In coordinate geometry we know this is x dash, this is y, this is y dash. Okay. In real number some ordered pair, suppose mean p equal to 2 3. The coordinate of p is 2 3. So we can represent this in the xy plane 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay. So now the p can be expressed as 2 and here 3. So this is the point 2, 3. Okay. Similarly, we can express more points in xy plane. Similarly, for complex number x plus iy. Let a complex number z equal to x plus iy. So there is this also correspond to a order pair x comma y. Okay. Let this is q point. Okay. So q point is can be represented geometrically in this plane. Okay. Let z equal to 5 plus 2y. Okay. Okay. Then the order pair will be 5 comma 2. Let this is the point A. Okay. And this can be represented in this plane as 5 and 2. So here we have 4 and let this is 5 and 2 is here 2. So this is the point A, 5 comma 2. Okay. Then we know this is the origin O. The coordinate is 0 comma 0. So if we draw a straight line between O and A, then weigh the distance of these two coordinates, 2 points. Okay. Then OA is equal to root 5 minus 0 whole square plus 2 minus 0 whole square. Okay. That means 5 square plus 2 square. So this is the mod of z. Okay. As z equal to 5 plus 2, we previously know the how we can find the mod. So this is the mod of z. So in complex number, if there is a question, find the distance between the origin and a point in xy plane, then you should write this modulus. Okay. Now just look. So this is the 5 square plus 2 square in general form when z equal to x plus iy. So in general form this can be represented as root over x square plus y square. Okay. When a equal to x comma y. Okay. Now the conjugate of z, that means z bar, equal to 5 minus 2y. Okay. So this is also correspond to a ordered pair. Then this is 5 comma minus 2. Let this is b. So 5 comma minus 2 is here. So here b 5 comma minus 2. Okay. So if we draw a straight line, then this is the distance between b and 0, and this is also 5 square plus 2 square. Okay. That means modulus of z. Modulus of z. And for general xy point, b is x comma minus y, and the distance will be root over x square plus y square. That means this is for z when z equal to x minus x plus 2y. Okay. Then b is called the mirror image of A in real axis. What is the real axis? In complex number system, this x-axis is called real axis. Okay, and this y-axis is called imaginary axis. Okay, so B is the mirror image of A in real axis. Okay, so that's all for today's class. We have covered all of the topics of complex number as per your syllabus, JEE and board exam CBSE. Okay, just practice of this class. And I always tell you that if you like this video, then please subscribe our channel for get more update. Thanks for watching our video.